Alright folks, let's see how this is working. There's the camera. Check. Alright. It's down here for safekeeping. Media window. Seems good. Alright, so here we go. First video lecture. Last thing we talked about. On Monday, we spent time going over epithelial tissue, and then we started on connective tissue. Connective tissue, most variable of the tissue types that we've got, come in these following forms. Okay. We have text. Point. We have fibrous connective tissue, and then that had its own set of subcategories, including loose connective tissue, which had areolar forms and reticular forms. Then, oops, back you go. Then there was the dense form of fibrous connective tissue, which had as its subcategories dense regular and dense irregular fibrous connective tissue. Good. Now, these forms, what made them different from one another was the quantity of fibers that you could find in the tissue, as well as the quantity of ground substance, because after all, that's what defines fibrous connective tissue, that you can actually see the fibers even with the naked eye, and when you see them with a microscope, you're going to find protein fibers making up a good part of the material between the cells. Now, any material between the cells is called matrix. The matrix of fibrous connective tissue is dominated by fibers and ground substance. Here, the fibers that you see are bundles of protein. Even the really skinny ones are multiple, probably thousands of molecules of protein. And then the empty space between them is not completely empty. It's filled with fluid and probably other dissolved components like glycosaminoglycans and proteoglycans and glycoproteins. So giving it sort of a thick, sticky, or gelatinous nature. Right? But the difference between loose and dense fibrous connective tissue had to do with the quantity of fibers that made up the matrix. Here you have loose stuff, and then here you have dense stuff. You can still see the individual cells, like those right there, that one right there, but then the rest of the blue stuff in between are just thick bundles of protein filling up most of the space. So if you want to try to simplify it somewhat, loose connective tissue is going to have more ground substance in it than protein in the matrix. Dense fibrous connective tissue is going to have more protein and less ground substance. Then we have the individual forms. Of the two kinds of loose fibrous connective tissue, areolar and reticular, the difference here has to do with the organization of the protein fibers. Here, areolar, the protein fibers are aligned generally in long, stringy lines. There doesn't be any sort of coordination. It's just an awful lot of them almost thrown down randomly. But this now makes it capable of stretching in multiple directions. Whereas reticular fibrous connective tissue tends to have a mesh that is organized into loops, or at least loop-like patterns. And so now we have something that creates more of a framework. This stuff can then be compressed and then spring back to its former shape, because it is made up mostly of reticular fibers, which are thin collagen coated with glycoproteins, so it has a spongy nature to it. Right? And then, once again, you can see it's still a loose connective tissue because there's relatively few protein fibers and a lot of ground substance in between them, there amongst the cells as well. Okay? So, again, loose, you're going to have fewer proteins and more ground substance in between your cells. Dense, you have more proteins and less ground substance. Dense regular, all the protein fibers are going in the same direction. And this gives it a great resistance to stretching in that particular plane, but no others. Whereas dense irregular fibrous connective tissue is going to have its protein fibers going every which way. Some going up and down, some going side to side, and of course some coming in and out of the screen at you. three-dimensional. All right, but now this tissue can resist pull in just about any direction. Maybe not as much as the dense regular can in one plane, but it can resist pull in all planes. And so we need that in areas where you're going to have those kind of unexpected pulls, unexpected strains. But there we go. Those are your various types of fibrous connective tissue. And admittedly, it's already a long list. But then we get into the other types of connective tissue. So this is the next category. Here, there we go, adipose tissue. Adipose tissue is fat. Right? So here you have a connective tissue made up primarily of adipocytes, fat cells. These fat cells often are going to be closely bunched together, especially if you have something that we consider to be fat tissue. It's going to be dominated by these cells. However, the cells do not have to touch, and that's, again, what's going to help to define your connective tissue. Cells that may be separated but don't have to be. So let's see, roll this down. Here's a picture that we have in our textbook and, of course, the PowerPoint. Individual bubble-like cells, but some of those cells are going to be separated by areas of more connective tissue, except lots of protein fibers and some ground substance. But it's true, generally when you are looking at adipose tissue, you do see big, thick clusters of these adipocytes, and each one of those bubble-like cells is where you find a storage vesicle for saturated triglycerides. In fact, if we go to, let's see, the histological ones, like this, here we go. Here's another shot of fat cells. Right? Each of these cells has its nucleus probably perched out towards the periphery, so it's not there in the middle because that's where the where the saturated triglycerides are. But the nuclei get pushed off to the edge of these enlarged cells. And let's see, there's a couple other ones. So bubble-like cells, some separated from one another by areas where you do have fibrous connective tissue. Okay. But still, that's the main shape that you should anticipate whenever you're